Today we are going to see another topic called JK flip-flop race around condition. This is a small topic. With this small topic, if you understood the logic, this will be leading to the next topic. So we know that JK flip-flop. So this is our JK flip-flops circuit. So what is the advantage of JK flip-flop? We know that the advantage of JK flip-flop over to SR flip-flop was when there is an input of 1 1, you will get a output of qn bar. That means the complement of whatever the previous state. So you will get the complement. But in the case of SR flip-flop, if 1 1 means you will be having an output of invalid condition. Okay, so that is the main advantage. But JK flip-flop is also having a small disadvantage. That disadvantage is called race around condition. What is race around condition? So what happens means when the input of JK flip-flop, for example, clock is also 1 and J is also 1 and K is also 1. What will happen? The output becomes complement of previous output, right? So suppose if you are having an output 0, once this condition comes, the output becomes 1. Again, what happens if you maintain the same input for a particular period of time or long period of time, the output continuously changes. For example, if it is 0 means it will change to 1. Again, it will change to 0. Again, it will change to 1. Again, it will change to 0 until either any one of the input is changed. Either clock can be 0 or either J can be 0 or K can be 0. Until that condition, the output becomes continuously pulsating. That means 0 1 0 1 0 1, like that it will change. Okay, so this condition, call it as a race around condition. Okay, so I will show you how it is working, that also. So assume this is our circuit which we have made it. So here this circuit will show, I can change the inputs of this circuit so that I can view the outputs of the circuit. Okay, so right now I'm starting the simulation. Okay, so this part will show you the clock sequence, that means output state in clock pulse or timing diagram point of view. Okay, so right now my J and K and clock everything is 0. So now I'm giving clock pulse. So what is happening here? You can see J is 0, K is 0, clock is 1, top means 1, bottom means 0. So output is 1. Previously it is assuming 1. So Q bar is 0. Okay. So I am changing the output now. Now what happens? It has been changed, right? So the input is changed. Now I'm starting to run the gate. Okay. Okay. I'm giving again 1. Okay. So now can you able to see? So when J is 1 and K is 0, output will be 1. We already know that. I am making it again. When J is 0, K is 1, what is our output? Okay, now it is becoming 0. Okay, and it maintains that only. Okay, you can see after that it maintains that. So now J is 0 and K is 1, output is 0. So this is as per our truth table. So our condition was to see whether all are 1 how it is going to work. Okay, so I'm now giving J also 1. Right now condition is all or 1. So let's see what happens. Can see that, okay, Q becomes 0, Q becomes 1, and Q bar becomes 0 here. Okay, so again I am not changing any value input. Repeatedly I'm running. Now Q becomes 0, Q bar becomes 1. Again I'm still keeping that and running the program. You can see there is a change in 0 and 1 in Q, right? Continuously it is changing. Okay, it is not stopping until I'm changing the input. Okay, you can see the pulse, it is becoming like anything. Okay, so you understood. Now I am changing the clock pulse to 0. Now let's see what happens. So now that's all. No more running of the clock pulses. So this is what happens when all are 1. You can see from here onwards, K1, J1 and clock is also 1. Output becomes what? It is just 1 0 1 0 1 0 1 0, like that it is changing, right? Until I made clock pulse 0. Okay. Once the clock pulse is 0, it maintains the previous state 1 as it is. Correct? So this condition we call it as a race around condition. Okay. So how to rectify this race around condition? So to rectify this race around condition, there are three options are there. So first option is, so the solution for that problem was, suppose this is our outcome. If there is a pulse, when clock pulse is high and J is 1 and K is 1, you will be having Q output 1 0 1 0 like that. Okay. So what is the solution for that? So assume that this is a pulse. So this is the time period, that means pulse, entire pulse time period, which is noted as T. Half of that on time will be T by 2. And assume and assuming that this period, that means this time period we call it as a propagation time, that we are noting it as TP. The solution for this problem is, if Tp is greater than T by 2, that means this clock pulse should be very, very less than Tp means. This propagation time means this race around condition will not occur. Okay. So next, another solution was, instead of going for level triggering, if we go for edge triggering, so this race around condition will not occur. So because at the time of edge triggering it will work, after that it won't work. So that is what happens. So at the time of edge triggering, this will not happen. Another possibility is utilizing master slave configuration. So this race around condition will not occur. So these three are the solutions for this race around condition. Next topic we are going to see about master slave and how the JK flip-flop is working in master slave, and how that race around condition is getting eliminated. So these things will be seen in the next topic. Thank you.